This is Jim Schnabel doing lecture number 36 in a series of biochemistry talks from the 7th edition of Leninger. And this is a reference to the previous talk I made where I referred to the biochemical mechanism of thiamine pyrophosphate, vitamin B1. And one of the issues with the text of the Leninger book is that we do not have the mechanism of the first of the complexes of pyruvate dehydrogenase. The first of the three enzymes involved in this complex takes thiamine pyrophosphate and decarboxylates pyruvate to form ultimately the 2-carbon acetyl-CoA, and then finally some reducing equivalents in the form of NADH, which give 2 or 3 ATPs. You can work out the mechanism with the dihydrolipoyl transacetylase here, but this is frankly not terribly informative, showing the binding of the vitamin directly to the pyruvate. So we wanted to do a little bit more of a deep dive into this, and to do so we need to look at the thiamine structure and its active carbanion form. So this is a pyrophosphate moiety here, there is a thiazole here, and a pyrimidine here. Thiazole is interesting because this is where the active moiety is, and you have the nitrogen and sulfur, which are called heteroatoms, and heteroatoms are non-carbon atoms that form the ring in an aromatic structure. The advantage of this type of formulation is that this proton can be pulled off very easily, and the electron pair that is formed at this carbanion is stabilized through the sulfur and the nitrogen here. So you can end up getting a Zwitter form with the nitrogen providing electron pair to this location with the stabilization of the carbanion here. And this is in fact the component that does react with the alpha carbon of pyruvate, and when you do that, this is where you get the adduct of thiamine pyrophosphate, creating the adduct with the pyruvate molecule, and then you end up reducing this and then oxidizing it and gain acetyl-CoA with coenzyme A migrating and ultimately knocking off the thiamine pyrophosphate. And this is another view of it right here, blown up. You can see the carbanion present here, producing this moiety here. There's resonance stabilization. This picks up a proton, and then you can get the reaction occurring. This is the carbanion pyruvate here. Getting this, the CO2 leaves. The electron pair kicks in, neutralizes this positive charge of the nitrogen, and then it can go back, and then you can pick up you get reduction of this carbon right here. And that's the structure of the mechanism that we get. And I hope that helps. Thank you very much.